All right, so in this video, we're going to continue to focus on our additive graphs, and we're going to focus today on how to graph these relationships without really needing the table of values. We're going to start here with the table of values just to explore some of the features of the graph, and eventually the goal is to be able to graph these additive relationships without needing the table. All right, so let's dive on in here. The first table of values that we have, when I focus in on the 0 point, we can see it's not 0, 0, so not proportional. But since there's a 5 here, it looks like we're going to have like an additive graph of plus 5. If I check, there's a plus 5 here, -1 plus 5 works, and -2 plus 5 works. So for our equation, let's go ahead and jot down that we've got y equals x plus 5. And we're going to start out, like I mentioned, we will start out with our training wheels on by just plotting these points. So if I go back to up 3, there's the first point plotted. If I go back 1 up 4, I've got that point. If I go 0, 5, I'm right here on the y-axis, and over 1 up 6. All right, cool. Let's connect those dots, and we should have a straight line. We're good to go. And let's take a look at some of the features of this graph. You'll notice that this line crosses either above or below the origin, and for this one, it's going to cross above the origin. It crosses above the origin here at 0, 5. The line crosses at 0, 5. Friendly reminder that that's called the y-intercept, and the y-intercept is found right here in the table of values. It's also found right here. It's the constant in the equation. So there's lots of places that tell us that it's going to cross at 0, 5. And the staircase is a 1 over 1, a 1 over 1, a 1 over 1. And you don't have to put the staircase in your notes. I just wanted to point that out to you. So the staircase from point to point is 1 over 1, which is technically still the 1 that's right there. 1 times x is still just x, so you don't need to see a 1 here. And you'll notice if I look at the rate of change here, these are going up by 1. So this went up by 1. These are also going up by 1. So the rate of change, my staircase is still a 1 over a 1. All right, so in additive graphs, the staircase is always going to be a 1 over 1. In additive graphs, the staircase will always be a 1 over 1. And that's actually what keeps them parallel to each other. Every additive graph is going to go up 1 over 1, up 1 over 1. And we'll see down here when we graph this next one, it should be parallel to this line. Let's start here by looking at the 0 point. So since it's not 0, 0, I know I'm dealing with additive. So 0, -1. And that lets me know here it's going to be y equals x minus 1. We're going to be taking away 1. Let's make sure that works. 2 minus 1 is 1. If I'm negative and I take away 1, I get more negative. And if I do a -4, I take away 1, I get more negative. Cool. All right, so now let's just do this the old-fashioned way. We're going to plot the points. We're going to go back 4, down 5. There's my first point. I've got -2, -3. Here's another point. I've got 0, -1. And I've got 2, 1. So over 2, up 1. Cool. So when I connect the dots here, and we can see I do have parallel lines. These lines right here, these are never going to intersect each other. These lines are parallel. We'll notice that this one now crosses below the origin at 0, -1. So I'm going to write the y-intercept right here. And friendly reminder that I can see it in the table of values. I could see it right here in the equation. It's also right there where the line crosses the y-axis. And my staircase is still going to be a 1 over 1. The staircase is always a 1 over 1. Now I'll point out here, if you look, see how this is up 2 over 2? Up 2 over 2. So this is like going up 2. These are up 2, while these are also up 2. And you guys know that anything divided by itself is a 1. So 2 over 2 is the same thing as 1 over 1. And if we look carefully in the table, if I go up 1 over 1, up 1 over 1, up 1 over 1, see my little staircase, the 1 over the 1 is still there. Going up 2 over 2 works. I could even try if I went up 3 and then over 3, it would work. Anything divided by itself reduces down to the 1. All right, cool. So let me just put my arrows back. And I'm just going to point out that if you know that the equation has a -1, you can start right here and then just use your staircase to build all these other points. That's going to be the shortcut where we don't need these table of values anymore. Okay. All right, so let's just kind of fill in some notes here. So our additive graphs, as I keep saying, they're always going to pass through our y-intercept. They don't pass through the origin anymore. They pass through the y-intercept, which is the constant in the equation. Okay. Now the reason this keeps happening is because anytime you input a 0, then the output is always going to be the constant. Here's what I mean. Let me use that table of values to show you what I mean by this. Anytime you input a 0, if you do 0 plus 3, your answer is 3. For the next one, if you did 0 minus 2, the answer is negative 2. If you did 0 plus 1, 0 plus 1, the answer is 1. And if you did 0 minus 4, the answer is negative 4. So anytime we input a 0, the output was always the constant. So the output was a 3, the output was a negative 2, the output was a 1, the output was a negative 4. Okay? Now let's fill in the rest of the table of values here. So if I do plus 3, so like negative 1 plus 3 is 2. 0 plus 3 is 3. 1 plus 3 is 4. 2 plus 3 is 5. Okay? For these, if we're doing minus 2 this time, anytime you're negative and subtract, you're getting more negative. Negative 2 minus 2 is negative 4. Negative 1 minus 2 would be negative 3. And of course, we have the y-intercept right there. If we have a plus 1 in the table of values, negative 1 plus 1 is 0. 1 plus 1 is 2. And 2 plus 1 is 3. And here for the last one, we're taking away a 4. So 1 minus 4 puts me at negative 3. 0 minus 4 is negative 4. Now if I do negative 1 minus 4, I'm at negative 5. Negative 2 minus 4 puts me at negative 6. Okay? So these table of values match these equations, and all I really wanted these here for was to kind of point out what I mean by this sentence, that anytime we input a 0, which is right here, I input a 0, I input a 0, I input a 0, I input a 0, the answer every time that I got was the constant that I had here in the equation, and we call that thing the y-intercept. That's what I'm saying right here. Now, friendly reminder that for these additive graphs, the staircase, the rate of change, is always going to be a 1 over 1. And I'll prove it to you. Here I'm going up 1. Here these are going up 1. So there's the up 1 over 1. These are increasing by 1, while these also increase by 1. So there's the rate of change. These are going up by 1. So are these. And last but not least, these went up by 1, and so did these. So the rate of change every time is going to be a 1 over 1 in your additive graphs. All right, so now let's flip over. And I have the table of values here, the training wheels, if you will, just to kind of check and verify afterwards. But really, y'all, I'm just trying to point out that if you know the equation is x plus 3, and you know this thing has a plus 3, you know it's going to cross at 0, 3. So this time, instead of starting at the origin, we don't start at the origin because it's not proportional. This time we just simply start here, and then we use a staircase 1 over 1, 1 over 1, 1 over 1. We could go down and back. Whoops, sorry, that one looks a little weird. Could go down and back, and when I connect, this should be the line for y equals x plus 3. And I have a table of values here to look for some points just to make sure we're on the right track. If I look for the point negative 1, 2, negative 1, 2 is on the line, we're good. 0, 3 is right there, that's my y-intercept, we're good there. If I go over 1, up 4, that point is on the line. And if I did over 2, up 5, that point is also on the line. So you can see how I was able to graph the line without actually plotting these points. I just used them to check at the end to make sure we're good, and we are. All right, now if it was x minus 2, this time it's a negative number, so it's going to cross below the origin at minus 2. And we use the staircase 1 over 1, 1 over 1, 1 over 1. Again, down and back works. So your additive lines are always 1 over 1 like this, and they just start at that blue point. Wherever the constant is, that's where they start. Now just to check, If I go back 4, down 6 right here, you can see that that would be on the line, so we're good here. -3, -5 is on my line, I'm set. If I did -2, -4, we're good. And if I did -1, -3, check that out, everything lines up perfectly. Now, while we're looking at x plus 3 and x minus 2, I just wanted to review in purple off to the side because I don't want you guys to forget. If it was x times 3, if it was proportional, proportional graphs always start at the origin. And this coefficient, it's not a 1. See, it's not a 1, it's a 3. So that's when we did the staircase 3 over 1, 3 over 1. Or down 3, back 1, down 3, back 1. So what I'm graphing right now, let me erase the other points real quick. What I just graphed from the origin going up 3 over 1 and then up 3 over 1, this is our proportional line. And I'll put those points back here in purple. The proportional went through the origin. And remember, I used the staircase right here, the 3 over the 1. That was the proportional graph from the previous unit, okay? So proportional went through the origin, and then I built a staircase. Today, you're actually starting at the constant right here, and then you're always using a 1 over 1 staircase, okay? It might help if you want to put underneath this that your staircase is a 1 over 1, that m is a 1 over 1. That might help. But now what I'm actually going to do is I'm going to erase the proportional graph because I don't want anybody to get confused thinking that there should be a proportional graph here on their additive notes. So if you've got that one though, this right here was the x plus 3. This is x plus 3. That's what we want to see. There's the plus 3. There's my rate of change. We're good. All right, now I'm going to come down here and kind of just review what we just said. So given the equation y equals x plus b, which is, x plus 3 or x minus 2, we use b written as an ordered pair. So the 3 is the ordered pair 0, 3. The -2 was the ordered pair 0, -2. We start there, and then we build a 1 over 1 staircase. This is what we did to just graph the line without the training wheels, okay? Now don't forget that the staircase is called the rate of change, and it can be found in 2 other places besides just going like, here's the staircase on the graph. There's the 1 over 1. It can actually be found in 2 other places besides the line. So if you see the equation, if you saw x plus 3 and I said, hey, what's the rate of change? The coefficient is still a 1 over 1 because technically I could put a 1 right there. Okay. Now the table of values. In the table of values, here's my up 1. And then here's my other up 1. So the 1 over 1 staircase, I could find it either in the equation as the coefficient or the table of values right here. There's the 1 over 1. In my next example, the x minus 2, here's the table of values. The rate of change is still a 1 over 1, y'all, because if I put a 1 right here, it doesn't change anything. 1 times x minus 2 is the same as just x minus 2. And again, you can see the rate of change in the table of values. There's the plus 1. Here's the plus 1. So it's in the equation right here. It's in the table of values right here. And then the line itself, here was the up 1 over 1 right here, up 1 over 1 on the line. So in the previous unit, we got really comfortable with the rate of change. The rate of change in this unit is a 1 over 1 staircase. And the new vocab thing in this unit, again, is the y-intercept, and it's going to be where the additive graph crosses the y-axis. All right? So now let's just practice. We're almost done here with this video. We're going to just practice graphing now without plotting points from a table of values. We're only going to use the table of values to check. So if I want you to graph this line, y equals x plus 1, you'll notice that it's additive. You'll then notice that the constant is a 1. So you'll notice that it's going to start right here. And then you'll remember, because it's additive, that you're just going to go up 1 over 1, up 1 over 1, up 1 over 1. And of course, the down and back gets the same set of points in a line. We'll connect those dots and put the arrows on the end. And now we have just graphed y equals x plus 1 without needing a table of values. Now, if we want to check, let's just check real quick. If I were to do a 2 plus 1, in the table of values, 2 plus 1 should be a 3. And let's make sure the ordered pair 2, 3 is there. If I go over 2 and up 3, it is on my line. Now, if I do 1 plus 1 in the table of values, 1 plus 1 should be a 2. 0 plus 1 is 1. Negative 1 plus 1 is 0. So we just want to verify real quick that these points are on my line so we know we're doing everything right. Negative 1, 0 is right there. 0, 1 is right here. And if I go over 1, up 2, I've got that point. So everything is all good to go. This is y equals x plus 1. All right, now let's do x minus 4. If this one has a plus 1, it crosses above the origin. Now the minus 4, it's going to cross below the origin at 0, negative 4. All right, so I'm going to start there. And then my staircase, 1 over 1, 1 over 1, 1 over 1. I could go down and back, down and back. All right, cool, let's connect. All right, draw my little arrows. Move my line slightly, it's kind of off. All right, so you guys should have this line now in your notes. And let's just fill out that table of values again and confirm that if we were to take away 4, let's do the table of values first. Negative 2 take away 4 is negative 6. Negative 1 take away 4 would be negative 5. 0 take away 4 is negative 4. There's the y-intercept. And 1 take away 4 is negative 3. So if I want to check, I got my negative 2, negative 6. That's there. If I go back 1, down 5, that's there. 0, negative 4 is here. And over 1, down 3. Look at that. All of them work out. So we have just graphed the line. And I don't want you to do this part, but I want to point out that they should be parallel. If I just click and drag this line and click and drag this line, see how they're parallel? These lines are parallel. All right. And now down here, the only reason I wanted to include these in the notes, y'all, is because let's just say you see a little bit of a curveball here. If you see the equation y equals x minus negative 2, I want you to be reminded that that's the same when you minus a negative, that's really adding. So this one is going to be x plus 2. It will cross above the origin at 0, 2, which is up here. And then when we build our staircase, 1 over 1, 1 over 1, 1 over 1, and then down and back, that's this line. And if we, again, just check with a table of values, the whole entire goal is to not need that table of values anymore. But if we just check, like if I get my calculator out real quick, and I want to plug in, let's just do this 1, okay? If I do 1 minus negative 2, if I do 1 minus, and then a 2, that's negative. So 1 minus negative 2 is a 3. So you can see it's really the same as adding. So like minus the negative 2 is the same as adding. So 1 plus 2 is 3. So 1 plus 2 is 3. So this would be a 3 right here. All right. 0 plus 2 would be a 2. Negative 1 plus 2 is 1. And negative 2 plus 2 puts me up to 0. So again, just checking, I've got that first point there. There's the negative 1, 1. Here's the 0, 2. Here's the 1, 3. Everything checks out. So we know we've graphed this line. We're good to go. And then again, mathematically, anytime you add a negative, that's the same thing. Adding a negative is subtracting. So that's like seeing x minus 1. And we talked about that at the beginning of the unit when we said anytime you're adding a negative, that is the same as subtracting. So when I subtract, I can call it an additive graph. So here, this one's going to cross below the origin at 0, negative 1. So see here, adding the negative 1, it is the negative 1. Careful if it's minus the negative 2 like over here, it's not down at negative 2 because minusing a negative is really adding. All right, now the thing we know we can rely on over here though is my 1 over 1 staircase. Boom, boom, boom. We'll come down and back and plot some points this way. All right, we'll connect. Straight line, there we go. And I think we should be all set. If we just take away 1, so take away 1, you're going to get more negative. Take away 1, you're going to get more negative. Take away 1, you're going to get more negative. And 0 take away 1, that's the y-intercept right there. And each of these points should be here. If I go back 3 down 4, I'm good. I'm all set. Back 2 down 3, I'm good. Back 1 down 2 is there. And there's my y-intercept. So we're all set. And now what you're going to try then on the next page is you're going to try to graph them. And notice there's no table of values. I took away the table of values. And at the bottom, you're going to answer the question that we've answered a lot so far in this video. The rate of change for all of these graphs is the same. The rate of change for all of these is that staircase that we've been talking about. And you'll see the rate of change. It's in the table of values every single time as well. So the rate of change is always the 1/1 anytime you have an additive graph. All right. That concludes this video. You're going to work on this next page now, and there will be a Google form for that. Thank you.